This is the latest image believed to show the third-generation Tesla bot, and it genuinely looks like a human in a robot suit. However, there's something even more interesting. Elon Musk is completely transforming Tesla by removing hundreds of welding robots from the production line of the Cybercab Robotaxi. In fact, not a single robotic welding arm will be involved in building this vehicle. The Cybercab's chassis is expected to be one of the most durable ever made, while also being among the cheapest to produce. Yeah. Elon Musk has acquired an unprecedentedly large GIGA Press, and with just this one machine, it could leave every other automaker stunned. With a massive size and a pressing force of up to 50,000 tons, it seems Musk is going all in on this machine in an effort to fulfill his claim that the Tesla Cybercab will have the lowest production cost of any vehicle, with output matching the combined volume of the Model 3 and Model Y. So why does Elon Musk need this machine? And what makes it capable of eliminating traditional welding robots? Why does Elon Musk need a new GIGA Press for the Cybercab? Yeah, as mentioned earlier, the logic behind this bold decision lies in Tesla's core goal to make the Cybercab the cheapest robotaxi in the world, priced at around $30,000, while producing it at massive scale equal to the combined production of the Model 3 and Model Y, meaning millions of units per year. It sounds unbelievable, but in reality, it's quite straightforward. To achieve that, production costs must drop significantly, assembly speed must skyrocket, and factories must become extremely flexible. Traditional welding robots are the biggest obstacle. In conventional car manufacturing, a single vehicle requires thousands of weld points, about 4,000 for a Model Y, leading to long, complex body shop lines that take up huge amounts of space, require high capital investment, involve complicated programming, and are prone to downtime. These welding robots lack flexibility when designs change, when dealing with assembly tolerances, or when switching to high-mix, low-volume production. That's why the Cybercab won't be built on the same production line as the Model Y or Model 3. Fundamentally, the Cybercab is smaller, as you can see when the two vehicles are parked side by side, and putting it on the existing production line would make a $30,000 price point completely impossible. So, Elon Musk has no choice but to create a radically simplified, yet far more efficient production line. What does that actually mean? Yeah. It means Elon Musk needs machines that are many times more efficient than those used in the old production lines. That's why he's going all in on a breakthrough piece of equipment, the 50,000-ton GIGA Press, a massive aluminum casting machine unlike anything the industry has ever seen, with a scale comparable to a multi-story building.
Like real fast. And then I guess maybe we need to just get even bigger casting machines? Sure, why not? Down, yeah, let's 50,000 tons.
The Model Y only uses a 6,100-ton GIGA Press, so you can imagine just how massive the jump to 50,000 tons really is. With a pressing force of up to 50,000 tons, this machine can cast large sections of a vehicle's chassis as a single piece in just seconds. There are even reports of test runs achieving casting cycle times of only 3.75 to 5 seconds, something Elon Musk himself has hinted at before.
I think it'll be able to produce a car ultimately in less than 5 seconds. Can you imagine a car coming off the line in less than 5 seconds? That's like, whoa.
Yeah, instead of stamping and welding together hundreds of small metal pieces like before, gigacasting creates massive, seamless cast structures for the front body, rear body, battery floor integrated with the interior, and side modules. As a result, the number of structural components in the Cybercab is reduced by around 50 to 60% compared to the Model Y, down to roughly 80 main parts instead of hundreds. This makes the chassis more durable than ever, since it eliminates weak points from welds. Overall rigidity is higher, weight is lower, and safety is significantly improved, all while achieving record low production costs. So what makes the 50,000-ton GIGA Press so special? The Cybercab's chassis manufacturing process begins by melting pure aluminum combined with recycled aluminum from previous castings in a furnace at around 850 degrees Celsius. After removing surface impurities, the molten metal is transferred through heated pipes into a sealed holding furnace, where the temperature is maintained between 750 degrees Celsius and 850 degrees Celsius. The new GIGA Press system uses a dual furnace setup: natural gas for the initial melting furnace and electricity for the holding furnace, allowing for precise temperature control with no smoke or dust, resulting in denser aluminum and a stronger structure. The empty space inside the holding furnace is filled with nitrogen to prevent oxidation. At the same time, technicians use argon gas, rotary degassing equipment, and silicon carbide filters to remove impurities and particles larger than 25 microns, ensuring the highest possible metal purity. Once the aluminum has been perfectly melted and refined, the 50,000-ton GIGA Press automatically moves to the mold lubrication stage. A robot sprays about 35 milliliters of soybean oil in a thin, even layer over the mold surface, similar to greasing a baking pan to prevent sticking. Next, the system creates a vacuum to remove any remaining air, and the molten metal is transferred from the holding furnace into the shot chamber. A piston, lubricated with about 8 milliliters of oil before each injection, then pushes the molten aluminum at high speed into the mold cavity. Once the mold is completely filled, the metal is held under pressure until it solidifies. The casting is removed while still glowing red at around 400 degrees Celsius and is immediately dropped by a robotic arm into a cooling water bath. The thermal shock from 400 degrees Celsius down to about 50 degrees Celsius not only cools it rapidly, but also locks the aluminum's molecular structure in place, eliminating defects and creating a much stronger, more rigid chassis. Meanwhile, the massive mold that just opened is cleaned and rapidly cooled by robots down to around 185 degrees Celsius, preparing it for the next cycle. The entire process runs so smoothly that a new chassis can be produced every 2 to 3 minutes. An astonishing speed compared to traditional welding methods that require assembling hundreds of steel components. Not a single gram of aluminum is wasted. All excess material trimmed off is fed back into the furnace for reuse. Each casting then undergoes advanced X-ray inspection systems to detect air pockets or microscopic cracks, ensuring a seamless, single-piece metal structure. The biggest challenge in this process is preventing the mold from cracking under the immense pressure of molten aluminum flow, which requires a clamping force of up to 50,000 tons for complete control. According to Elon Musk, to turn what once seemed impossible into reality, Tesla has built a completely unique technology ecosystem. From ultra-fast cooling systems and intelligent mold release mechanisms to AI-driven quality inspection processes. This is a combination that no automaker has dared to attempt at such scale. This gigacasting process doesn't just give the Cybercab its most durable chassis, it also makes it the fastest built in automotive history. By casting large modules as single pieces, the number of components is reduced by 50 to 60%, completely eliminating the need for thousands of weld points found in traditional vehicles. Combined with Unboxed manufacturing, the vehicle is divided into 5 major modules: front, rear, structural battery plus interior, and 2 side sections, which are produced in parallel and then joined using structural adhesives and high-precision laser bonding. The Cybercab's simplified design, no steering wheel, no pedals, and pre-colored plastic body panels, makes welding robots entirely unnecessary. The production line now resembles electronics assembly more than traditional car manufacturing, faster, cleaner, with fewer defects, and saving around 40% of factory floor space. In 2019, the 6,100-ton GIGA Press used for the Model Y marked the first major breakthrough. At that time, Tesla was the only company with this technology, and it sparked intense discussion due to its almost unbelievable usefulness. This machine replaced more than 70 individual parts with a single-piece aluminum casting for the rear underbody or front structure. A pressing force of around 6,100 tons was enough to produce medium-sized components for the Model Y. Thanks to gigacasting, Tesla significantly reduced the number of parts, eliminated hundreds of weld points, shortened production time, reduced vehicle weight, and increased structural rigidity. However, the process still required multiple casting machines for different modules, combined with traditional welding lines in the body shop. Casting cycles typically took several dozen seconds to over a minute per shot, and factories still required large floor space for final assembly. The Model Y also retained a complex design with a steering wheel, pedals, and multiple body panels that require painting and welding, so welding robots continued to play a critical role. Then in 2023, with the launch of the Cybertruck, Tesla needed a larger GIGA Press for a pickup truck that is bigger, heavier, and more durable, featuring a stainless steel structure. Elon Musk did not hesitate to ask IDRA to build a 9,000-ton casting machine, with about 1.5 times the pressing force of the 6,100-ton version. This enabled the production of much larger components, such as a single-piece rear frame or vehicle floor, replacing hundreds of parts. The Cybertruck requires high durability to withstand impacts and heavy loads, so the 9,000-ton machine focuses on producing strong castings while reducing weight compared to traditional welded steel methods. Even so, the Cybertruck remains a more traditional vehicle, with a complex off-road design, numerous mechanical components, and an assembly process that still requires some welding or joining steps. This machine is larger and heavier, but it still operates by casting large modules separately, without reaching full multi-mold integration or ultra-fast cycle times. The 50,000-ton GIGA Press for the Cybercab is completely different in both scale and purpose. Its pressing force is about 8.3 times greater than the 6,100-ton machine and 5.5 times greater than the 9,000-ton version, enabling the casting of much larger structures and potentially even multiple vehicle frames at once. Elon Musk has suggested it could cast up to 5 frames or multiple modules in a single cycle. The machine's massive size far exceeds previous generations, requiring ultra-fast cooling systems, specialized high-strength molds, and intelligent mold release mechanisms. The Cybercab is designed to be extremely simple: no steering wheel, no pedals, pre-colored plastic body panels that don't require painting, and a structural battery pack. As a result, the 50,000-ton machine can cast larger modules or even most of the vehicle structure while reducing the number of components by 50 to 60% compared to the Model Y. The biggest difference lies in the unboxed manufacturing process. Instead of casting individual parts and then welding them together along a long, linear production line like the Model Y and Cybertruck, the Cybercab is divided into 5 modules that are produced in parallel. These modules are then assembled using structural adhesives and high-precision laser bonding, with little to no need for welding robots. One of the biggest psychological barriers to gigacasting has been the concern that if the chassis is a single continuous piece, any damage would require replacing the entire vehicle. However, Tesla has turned this perceived drawback into an advantage through a sophisticated modular repair system. Instead of casting the entire vehicle as a single piece from front to back, the structure is divided into 3 strategic sections: front, center, and rear. The crumple zones at the front and rear are designed as physical bridges, bolted onto the main casting through specialized high-strength joints rather than being permanently fixed. In the event of minor to moderate collisions, only these sacrificial modules are deformed. Technicians no longer need to use welding equipment or frame-pulling machines to realign countless small components, tasks that can compromise safety. Instead, repairs focus on diagnosing the damage and simply replacing the affected module with a newly manufactured, precision-made part. This shift also challenges the assumption that electric vehicles always come with high insurance costs. According to a 2025 report by Thatcham Research, cast structures can actually reduce the complexity of assessing damage. In traditional welded frames, a collision can weaken weld points or adhesives in ways that are difficult to detect, often requiring extensive teardown. By contrast, with cast structures, damage is either clearly intact or visibly cracked. As a result, combined with advanced diagnostic tools, sensors, and handheld X-ray devices, damage can be identified almost instantly. Vehicles using gigacasting are estimated to reduce repair time to around 30% of current levels, directly lowering labor costs, the largest component of repair bills. This bolt-on instead of welding revolution not only improves economic efficiency, but also elevates the overall maintainability of vehicles, while providing a more stable cast structure for suspension and drivetrain systems. After replacing a damaged module, the vehicle can return to nearly 100% of its original geometric precision, something that traditional straightening and manual welding methods rarely achieve. It can be said that gigacasting is transforming auto repair from a craft based on hands-on experience into a high-precision assembly process. This is why insurance companies may eventually lower premiums, while owners can feel confident that their vehicles are not fragile. In fact, they are more durable and easier to restore than ever before. If the Model Y once amazed the automotive industry by achieving a production rate of 1 completed vehicle every 33 to 40 seconds at Giga Shanghai, the Cybercab is preparing to shatter that record dramatically. Thanks to the advanced 50,000-ton GIGA Press system combined with the revolutionary Unboxed manufacturing process, the chassis and main modules of each Cybercab can be completed in just about 5 to 10 seconds per casting cycle. At this speed, the Cybercab is aiming to become the fastest produced vehicle in Tesla's history, while setting a new benchmark for the global automotive industry. With the production version revealed, Tesla continues to follow its minimalist philosophy but has taken it to an entirely new level. The vehicle has no steering wheel and no pedals. Instead, a large 21-inch touchscreen serves as the central control interface. The seats are designed like a mobile sofa, providing maximum comfort for passengers throughout the journey. The materials used are synthetic leather, durable, easy to clean, and well-suited for the continuous operation of a robotaxi service. One of the most notable innovations is accessibility for visually impaired users. The Cybercab could become the first vehicle designed with braille labels on key controls, allowing users to identify and operate functions such as emergency stop without assistance. This represents a major step forward in inclusive design, especially in a driverless vehicle where passengers must be fully independent. The door system has also been significantly improved. In the past, Tesla vehicles were often criticized for complex door mechanisms, particularly in emergency situations. With the Cybercab, Tesla integrates both electronic and mechanical systems into a single handle. A light pull opens the door electronically, while a stronger pull activates a mechanical backup. This ensures passengers can exit easily, even in the event of a power failure, meeting increasingly strict safety requirements from regulators like the National Highway Traffic Safety Administration. From a manufacturing standpoint, the Cybercab also represents a revolution with its unboxed approach. Instead of assembling a car from a single complete frame, Tesla divides the vehicle into large modules, such as the front, rear, battery, and interior, which are built in parallel and then joined at the final stage. This approach reduces factory footprint, increases production speed, and can cut costs by up to 50%. Combined with gigacasting technology, Tesla aims to achieve a production time of under 10 seconds per vehicle, an almost unprecedented figure in the automotive world. That said, the Cybercab still faces significant challenges. Full self-driving technology has yet to reach complete reliability, and Tesla is being compared to competitors like Waymo, which has already deployed thousands of vehicles and accumulated hundreds of millions of kilometers of real-world data. Additionally, Tesla's reliance primarily on cameras instead of LiDAR continues to spark debate among experts regarding environmental perception in complex conditions. Estimates suggest that Tesla's robotaxi accident rates may be higher than those of human drivers, although most incidents occur at low speeds. This indicates the technology is still evolving and requires more time to prove its safety in real-world conditions. Elon Musk has acknowledged that initial production will be slow due to the entirely new process. However, once ramp-up is complete, production speed is expected to increase in a parabolic curve, targeting roughly one vehicle every 10 seconds at scale. When large-scale pilot production is complete, the Tesla Cybercab could be ready to flood city streets, ushering in an era of affordable, high-speed autonomous transportation. So, do you think gigacasting will replace traditional car manufacturing? And would you trust a fully driverless Cybercab for your daily commute? Thanks for watching. If you enjoyed this deep dive into Tesla's Cybercab, hit like, subscribe, and turn on notifications for more future tech breakdowns. Let us know your thoughts in the comments, and we'll see you in the next video where we explore what's coming next in the world of innovation.